Hello everyone. In this video, we'll continue with the whole life annuity deal. And here we'll have the third approach to get the expected value of Y here. And in this third approach, we will make use of the relationship with the whole life insurance. Recall the present value random variable Y for annuity, which equals A double dot angle Kx plus 1. We have this expression. And then for whole life insurance, the present value random variable Z is new to the power Kx plus 1, and this term appears in the expression for Y. So we will replace this new to the power Kx plus 1 with the random variable Z, and we have the YZ relationship, Y equals 1 minus Z over D. To get the expected value for Y, we simply take the expected value of 1 minus Z over D, and the expected value of Z is simply big A of X. And we can rewrite this as big AX equals 1 minus D times A double dot X. And here we relate the expected value for the annuity, whole life annuity, with the whole life insurance. How about the variance? The variance of Y, we have the variance of 1 minus Z over D. D is a constant. So we have 1 over D squared and then times the variance of Z. And in terms of the big A notation, the variance of Z equals to this. The pre-superscript AX minus the square of big AX. And here we have the variance of Y, the variance of the whole life annuity deal in terms of the big A notation. Okay, we are going to relate the big A notation here with the A double dot X to get the variance of Y in terms of the annuities, the small A double dot. We have this relationship. The second moment, the pre-superscript 2AX, the second moment for the whole life insurance, equals to 1 minus pre-superscript 2D times the pre-superscript 2 A double dot X. And recall the definition of this pre-superscript. We evaluate the delta in the first expression, replace this delta with 2 delta, then we get the pre-superscript 2 here. And for the pre-superscript 2D, we have the relationship, okay, e to the power minus delta. Delta is the force of interest, which equals 1 minus D. Replace delta with 2 delta. And then we can get the corresponding rate of discount. At double force of interest, the rate of discount from D to 2D minus D squared. So pre-superscript 2D equals 2D minus D squared. And recall that the pre-superscript 2 A double dot X is not the second moment for the annuity. This is not the expected value of Y squared. This is not the second moment. All right, with these two expressions, replace the pre-superscript 2 AX and AX, and we get this lengthy expression. We try to simplify that. We get this part, and then doing more simplification, we get this expression. All right, so here, if you simplify the last term here, the D squared cancel out, we get the very last term. And then consider these two terms, the D squared cancel, and we get the second last term here. And then the remaining part, we get the first term. So this is the expression for the variance of Y in terms of the annuities. This is the variance of Y. And recall that the square of A double dot X, A double dot X is the expected value of Y. So this last term corresponds to the expected Y square. And by the definition of the variance of y, these two terms together forms the value or the expression for the expected value of the y squared. There's no need to memorize it because we seldom use this to get the expected value for y squared. All right, this is the theory part. Let's move on to an illustration. Given the life table, okay, using the life table, remember that the interest rate should be 5%. All right, an illustration, okay, at the interest rate 0.05, the insurance, okay, the whole life insurance at age 25, the expected value 0.06147. This is given in the table. Suppose we want to make use of this value to get A.25, the whole life annuity deal issued to an individual at age 25. The YZ relationship, we get 1 minus A25 over D. We have A25, and then we can get the expected value of Y here. A.25 is 19.7091. And in fact, you can get the value for the A.X along this column in the table. To get the variance, make use of this relationship. 1 over D squared, and then the variance of Z. The variance of Z here is the pre-superscript 2A25 minus the square A25, and we can get these two quantities from the table. Doing the substitution, we get the variance, 1.8087. All right, another example. A portfolio for a group of 100 independent lives, all at age X, given that each life is paid $1 at the beginning of each year if the policy holder is alive, and then the following three quantities. Big AX is 0.23, please superscript 2AX, the second moment of the insurance, 0.07, I is 5%. Use the normal approximation to calculate the initial size of the fund required in order to be 90% certain of being able to make the payments for these 100 life annuities. All right, let Y be the present value random variable for one life. The expected value of Y, make use of the YZ relationship. Y equals 1 minus Z over D, and the expected value of Z is AX. We are given that AX is 0.23, and D is what I over 1 plus I. So we get the expected value for Y, 16.17. And then the variance of Y, 1 over D squared, and then the variance of Z. Doing the substitution, we get the variance of Y, 7.5411. All right, the portfolio. Let S be the aggregate present value random variable for the 100 lives. So we need to get the expected value of S and the variance of S, and then use the normal approximation. The expected value of S, 100 times the expected value of Y, and then the variance of S, 100 times the variance of Y. 90% certain to make the payments. So we have the probability statement, the random variable S less than or equals the small s, we need to get this value equals to 90%, 0.9. Using the standard normal random variable calculator, the 90th percentile corresponds to the value 1.28155. we get this expression. We have the expected value and the variance of S respectively. And then we can get the answer, 1652.19. All right, that's it for today's video. Thank you for watching and see you in the next video.